Hello everybody, I welcome you all to NCAS geology class. In my previous class I have already discussed about the morphology of crystals, the faces, edges, solid angles, and how the faces are being represented through West parameters and Miller's indices. Now I will discuss about the problems which are related to Miller's indices. Let us discuss. Indices are given from which West indices are to be derived from the West parameters. First we have to write the intercepts along A, B and C axis. Then we have to take the reciprocals, remove the fractions and write them in form of HKL. That is the way how we present the Miller's indices for the faces. Let us say a plane cuts the axis at 2A, 3B and 4C. Find its Miller's indices. So intercepts are 2, 3 and 4. 2, 3 and 4. If we take the reciprocals, it becomes half, 1 by 3 and 1 by 4. When we remove the fractions, we have to multiply them by 12, which is the LCM of 2, 3 and 4, and we get 6, 4, 3. So Miller's indices is written as 6, 4, 3 by removing these commas. So 6, 4, 3 is the phase symbol or Miller indices for the phase which has intercepts 2A, 3B and 4C. Similarly, if a plane cuts the axis at 2A, infinite B and 3C, its indices can be found out in following way. The intercepts are 2, infinity and 3. If we take the reciprocals, it becomes half, 0 and 1 by 3. When you remove the fractions, it becomes 3, 0 and 2. So indices for a phase having intercepts 2A, infinite B and 3C, it becomes 3, 0, 2. Similarly, if the intercepts are minus 2A, 3B and 1C, in that case, if we take the reciprocals, it becomes half minus half, 1 by 3, 1. When you remove the fractions, it becomes minus 3, 2 and 6. So indices are 3 bar, 2, 6. Miller's indices for a phase having intercepts minus 2A, 3B and 1C. So this is how we derive the indices from the West parameter. Now finding West parameter from Miller's indices. So rule is that for the plane HKL we have to take the intercepts. Intercepts are A by H, B by K, C by L. So let us find the West parameter for a plane 3, 2, 1. So its intercepts are A by 3, B by 2, C by 1. This is the intercept formula. So A by 3, B by 2, C by 1. Because 3 to 1 is the Miller's indices. So it cuts A axis at 1 by 3 distance, B axis at half the distance and C axis at unit distance. Let us find the intercepts for a phase having Miller's indices 2, 1, not. So its intercepts are A by 2, B by 1, C by 0. So intercepts are half A, 1B and infinity C. Similarly, if we can find out the intercept for 1, 1, 1, the intercepts are 1A, 1B, 1C. It cuts all the three axes at unit distances. Let us find out the problems related on axial ratio, where B is always taken to be unity, always taken to be unity. So if the axial, suppose axial ratio has been given as A is to B is to C as 1 is to 2 is to 3, so we have to reduce this B to be equal to 1. So how can we get it? So we have to divide it by 2. So let a plane has the following intercepts: 1A, 2B, 3C. Find actual intercepts lengths. So actual axis length is A is equal to 1 unit, B 2 unit, C 3 unit, because they are in the ratio of 1 is to 2 is to 3. But plane intercepts are 1A, 2B, 3C. So intercept length will be 1A, 1 into 1 is equal to 1 for axis A, 2 into 2, 2B is 4 for axis B, and for 3C, 3 into 3, it becomes 9 for axis C. So intercept lengths are 1, 4 and 9 along A, B, C axis. These are the intercept lengths. If the axial ratio is given 1 is to 2 is to 4, for A is to B is to C, and the plane is 2, 4, 1, find its actual intercepts, actual length in the axis. The plane is 2, 4, 1. So waist parameter or intercepts will be A by 2, B by 4, C by 1. So using axial lengths, because A is 1 unit, B is 2 unit, C is 4 unit. So using axial length, A is equal to 1, B is equal to 2, C is equal to 4. And we have a waist parameter A by 2, B by 4, C by 1. That will be equal to A will be 1 by 2, P will be 2 by 4 or it is equal to 1 by 2, C will be 4 by 4, C will be 4 by 1, so it will be 4. So the intercepts are 0.5, 0.5 and 4 along the A, B and C axis. Thus, relation for indices is equal to the reciprocal of intercepts. The intercepts are A by H, B by K, C by L for a face having Miller's indices HKL. So we could determine the intercept lengths along the axis by taking into account the axial ratio. Problems related to hexagonal Miller indices. If a plane in hexagonal system has intercepts A1, A2, infinity A3 and C, find its indices. Its indices will be 1A1, 1A2, infinity A3 and 1C. If you take the reciprocals 1 by 1, 1 by 1, 1 by infinity and 1 by 1. It will be 1a, 1a1, 1a2, 0a3, 1. See? So indices will be 1, 1, 2 bar 1 because the hexagonal symbol is HKIL. These three, they are summed up to produce 0. So we have the A intercept 1, B intercept 1, so C intercept must have to be minus 2. That's why it is 1, 1, 2 bar 1. This is the hexagonal Miller indices. So this thing we have to remember. We have to remember H plus K is equal to minus I. That is in case of hexagonal system. Now let us see how we draw the plane from the Miller indices. The Miller's indices give a set of parallel planes. 1, 2, 2, 2, 4, 4, 3, 6, 6, all are parallel. Their indices are all 1, 2, 2. If we take these indices, they are all planes which are parallel to 1, 2, 2. So this is A, B and C. So it has given A 1 unit, B 2 unit, C 2 unit. First one. 1, 2, 2. Second, it is 2 unit, 4 unit, 4 unit. Third, this place. This is 3, 6, 6. So 3 planes. These 3 planes, they are parallel and can have the same indices, that is 1, 2, 2. Draw not one plane. How can you get it? Not one plane. We have to take the intercepts. This is the Miller indices, so we have to take the intercepts along A, B and C axis. So plane is 1, 1, 0. Intercept will be 1 by 1, 1 by 1, 1 by infinity. So intercepts are 1, 1 and infinity. So face chords the axis at 1A, 1B and infinity C. Intercept 1A, 1B and is parallel to, so this is the plane which chords A and B and is parallel to C. It is parallel to C. So this is B, this is A, this is the plane. So plane runs like this. This is the plane which is having intercept 1, 1, not. A intercept, B intercept and parallel to C. So in this manner we can draw the planes from the Miller's indices, draw 1 to 1 plane. So we have to take the reciprocals. These are the reciprocals, and reciprocals are the intercepts. So it is 1, it is half, this is 1. So along A 1 unit, along B half unit, along C 1 unit. So this is the phase. Draw two not one plane. So intercept is half along A, infinity along B, 1 along C. Half along A, parallel to B, and cuts C at 1 unit C. So B, C, A, C, and they are joined. They are parallel to this B axis. That's why this is the plane. This is the plane. Not 2, 0, 0. So you have to draw the axis like this. We have to show the origin in such a manner that we can find out the -2 line. If we consider this at the 0, this is A, this is B, this is C, or we can say this is A, this is B, this is C. So this is positive A, this is positive B, this is positive C. So -2 will be this unit. It's -2. Then it is parallel to B, parallel to C. So the plane will be this plane. This plane is parallel to B axis. This plane is parallel to C axis, and this plane is cutting A at -2. So this plane is -2 not, because this is the origin. On the back side 2 units we have, or -1/2 unit. If you take the reciprocal, it becomes this distance is -1/2. So this is origin, -1/2, then this is the phase. -2 not. Draw the direction 1, 2, 3. If we represent the phase symbol in square brackets, it will indicate the direction. It is not the phase symbol. So how can you indicate this direction? This is, if you take the vectors, it will be 1A, 2B, 3C. So first we will take along. So in order to accommodate this direction, point within the unit cell, let us reduce the vectors, because it becomes 3 unit, 2 unit, 1 unit. We have to reduce it so that it can be accommodated within the unit cell. So it will be 1/3, it will be 2/3, so that it will be 1. 3/3, it will be 1. So along C it will be 1, along B it will be 2/3, along A it will be 1/3. So that this direction can be shown within the unit cell. So along A, this is the A. Along A we go 1/3. Along B this is 2 by 3. So along we move 1 by 3, then parallel to B 2 by 3, then parallel to C, this is 1 unit, this is 1. So along A 1 by 3, parallel to B 2 by 3, parallel to C 1. So this is the origin point. This is the final point of C. So this origin and C, they are joined. So this is the 1, 2, 3 is the direction. 1, 2, 3 direction is this one. This is the 1, 2, 3 direction. That has been shown. So from the origin at the intercept end of 3 is C, we draw the line. Now we will discuss how interplanar spacing can be found out. That we can discuss. So to find the interplanar spacing, if this is A axis, this is B axis, this is C axis. Let us say this is a plane, this is the plane. So how much distance this plane is from this origin O? So from O we have to draw a perpendicular to this face or a normal. And this distance from this point to this point will give the interplanar spacing, spacing from the center, from the origin. So how can I find out this interplanar spacing? That we will see. Different planes in crystals can be measured with respect to their spacing from the center. This distance is called interplanar spacing. If the face is a scale, its distance from the center or perpendicular distance d, that is interplanar spacing, is given by d is equal to a by root over of h square plus k square plus l square. And this is the formula for a cubic shell where A is equal to B is equal to C. This is the formula to find out the interplanar spacing in case of cubic shell. Let us say ABC is the phase, it has indices HKL. So OA intercept will be equal to A by H. OB intercept will be B by K. If it is cubic cell, then A by H, A by K, and OC will be A by L. So cubic cell A is equal to B is equal to C. Otherwise it would have been A by H, B by K, C by L. So this plane will have distance D from the center, the perpendicular distance from the perpendicular distance of the plane from the center. Let us say this is the plane. This is the plane of the face. This is the perpendicular distance. So this perpendicular distance from A axis, B axis and C axis, this is the D perpendicular distance. This, let us say this is ON. ON makes alpha with OC, beta with OB, gamma with OA. If we take their cos angle will be ON divided by OC. This is the alpha. So it will be D by A by L. Cos beta will be D by A by K. Cos gamma will be D by A by H. If we take the squares, cos square alpha plus cos square beta plus cos square gamma, it will be D square by A square, L square plus K square plus H square. But from geometrical relation, cos square alpha plus cos square beta plus cos square gamma is equal to 1. That's why D square becomes equal to this one and D becomes A by root over H square plus K square plus L square, for which is the spacing for a face HKL in cubic cell. If we take, I can derive this formula. Let us see, let us take, if it is not a cubic cell, we can have, these are the three axes. A, let us say this is B, this is C. Let us say this is a face, this is the face which is cutting A, this is origin, let us say it is O, this is OX, OY, OZ, and let us draw perpendicular to this plane. This should be N, and we can draw this angle will be alpha. We can draw this angle will be beta. We can draw this angle will be gamma. So we have right angle triangles. This is ON, this is alpha, this is D, this is along C axis, OZ. So OZN triangle is a right angle triangle with Z 90 degree. So cos alpha will be D by OZ. OZ is the intercept along C. So this will be D by C by HKL L, C by L. Similarly, we can get cos beta. Cos beta will be D by B by K, and cos gamma it will be D by C by H. So this becomes D square. So here it will be B square, it will be C square. D square, A square, D square by A square. If you take the square, cos square alpha is D square by B square by K square. K square will come to the top. L square, A square, B square, C square, they will come to the bottom at the denominator. So here this will be here. If we take this square common, because this is equal to 1. So if we take this square common, H square plus K square plus L square it will be A square, it will be B square, it will be C square. This will be equal to 1. So D square will be A square by H square plus B square by K square plus C square by L square. So D will be root over of all these. If it is a cubic cell, A square is equal to B square is equal to C square. So this will be 1 by H square plus 1 by K square plus 1 by, or this will be A square, it will be common. A square will be common, and it will be A by, it will be equal to A by root over of H square it will be equal to A by H square plus K square plus L square. So if we see it again from this is the final structure. This is equal to 1 D square by A square, D square by, this will be B square, D square by C square. So D square will be common, L square by A square, K square by B square plus H square by C square. This will be the so this will be equal to 1. So this is the, so if we bring it to this side, this will be 1 by L square by A square plus K square by B square plus H square by C square. This will be D or D square. If we take D, it will be root over of L square by A square plus K square by B square plus H square by C square. So this is the formula. D is equal to 1 by H square by A square plus K square by B square plus L square by C square whole root over. This will be D. Or if A is equal to B is equal to C, in that case it will be D will be A by root over of H square plus K square plus L square, where D is the interplanar spacing, H, K, L, they are the Miller indices. So this is the formula. This is the formula for interplanar spacing, or we can this is the formula for interplanar spacing. If it is, this is the formula for interplanar spacing in case of cubic cells, cubic unit cells. So by putting this formula, we can find out the interplanar spacing for different faces. Let us see a problem. A silver crystal has FCC structure and its face-centered cubic FCC structure, and its atomic radius is 1.44 angstrom. If it is atomic radius is given FCC structure, we can find out the relation for A. A will be 4r by root 2. This is the for FCC structure. So r is the radius given, so it is multiplied with this one, so 4.073 angstrom becomes the lattice constant, or it is the axial length A. Now D for 220, 220, 200, 111 planes we can find out separately. D for 220 is equal to A by H square plus K square plus L square whole root over. So accordingly we put the value of H is 2, K is 2, L is 0, 2, 2, 0. They are squares, and thus we find out the value interplanar distance for face 220. We can find the interplanar spacing for 200 by taking H is 2, K 0, L 0. So this has been shown here. And for 1, this is the value. So we have to remember this formula. And if it is FCC structure, what is the length of A? A is given by, it is face-centered cubic. It is face-centered cubic. For FCC, A is equal to 4r by root 2. That I will deduce in my subsequent lectures. Let us say a crystal lattice plane 3 to 6 makes an intercept of 1.5 angstrom on x-axis of a crystal having lattice constant x is 1.5 angstrom, Y 2 angstrom, Z 2 angstrom. So these are the ABC. ABC are given. Find the Y and J intercept, because this lattice plane intersects X at 1.5 angstrom, thrice this distance. So find Y and Z intercepts. So X is 1.5. So OA intercept will be A by H. A is given 1.5 angstrom. So phase is 3, 2, 6. We know intercept on any axis is given by A by H, B by K, C by L, if phase is HKL, having Miller indices HKL. So here we have, this is A, this is B, this is C, and we have, this is H, this is K, this is L. So intercept on A will be A by H, 1.5 by 3 is equal to 0.5 angstrom. In OB along Y, we have to find out along Y and Z. So if we take into these lengths, we get 0.1 angstrom, and along OC for Z, it will be 1.3 angstrom. So these are the axial lengths. These are the actual intercept length along A, B and C axis. But it has been shown that the intercept here, OA intercept is coming out to be 0.5 as per these lattice constants for this space. But it has been shown that it makes an intercept of 1.5 angstrom instead of 0.5 angstrom. It meets thrice this value. So all these values will have to be thrice. All these values will have to be thrice. So as intercept X axis is given to be 1.5, which is thrice the OA intercept. So intercept Y and Z will have 3 times their value. So Y will be 1 angstrom into 3 angstrom. Z will be 1 by 3 into 3 into, it will be 1 angstrom. So this is the intercept, actual intercept value of the phase 3 to 6 in a cell structure having the axis length 1.5 angstrom, 2 angstrom and 2 angstrom for A, B and C axis. Let us find out the axial ratio from actual intercepts. Find the axial or the Miller indices of a phase, that is a scale that cuts X, Y, Z actual distance, which are the actual distance. So axial ratio is A is to B is to C. Miller indices is given HKL. So actual intercept is X, Y, Z. So actual intercept on A is A by H. Actual intercept on B is B by K. Actual intercept on C is C by L. It has been shown that they are X, Y and Z. So A will be Hx, B will be Yk, C will be Zl. Intercepts are derived as A by H, B by K, C by L for phase HKL on ABC axis. So x by e the OS parameter. Reciprocal of OS parameter is L. So 1 by x by a is equal to L. So Miller indices, which is L. So x is equal to a by L. This is x a by h b by k c by L. That has been shown here. So a is to b is to c is equal to. So what we have to find out? The axial ratio from actual intercepts. Actual intercepts are x, y, z. So we have to multiply them with the Miller's indices HKL. So A will be Hx, B will be Yk, C will be Z. Here I have shown ZL. So A is to be Hx, is to Yk, is to ZL. Let us say Fs is 1, 1, 1. It has actual intercept 2, 4, 6. Find its axial ratio. This is x, this is y, this is z, this is h, this is k, l. Hx will be a, yk will be b, z, l will be c. Hx, find out, ky, z. So we got 2:4:6, or it is 1:2:3. Plane 2, 4, 1. Actual intercepts are 1, 2, 4. So axial ratio will be multiply them. That has been given. A is to be 1:4:2. So this has been explained here. Here we can find out. So A is equal to Hx, B is equal to Yk, C is equal to ZL. For HKL are the Miller's indices, X, Y, Z are the actual intercepts from which we can get the axial lengths A, B and C. Now let us discuss what is crystallographic intercept versus actual intercept. Crystallographic intercept is the Miller indices. Actual intercept is the distance that a phase covers along the axis. If these are the axis, at hard distance the phase covers, that gives the actual distance that the phase covers along the axis. So that is actual intercept. From the actual intercept we can derive the axial ratio. So actual distance, it is the actual intercept means distance that a phase covers on the axis. This is the phase. It covers A at this distance, B at this distance, C at this distance. So this is the distance, this is the distance, this is the distance, actual intercept. Suppose a plane covers axis at 2 cm, 4 cm to 6 cm. So these are the actual intercepts. Crystallographic intercepts in terms of unit cell edge lengths are A, B, C. Thus, crystallographic intercepts are noted for the phase depending upon how many times of the length A, B, C are cut along A, B, C axis. Along A, B, at what distance the phase cuts. Along B, at what distance the phase cuts. Along C, at what distance this phase cuts. Say 2A, 3B, 2C. Thus, relationship actual intercept is X, Y, Z. Axis length is A, B, C. Crystallographic intercept will be X by A. Actual intercept. Crystallographic intercept will be X by A, Y by B, Z by C, because it the 1A, 2A, 3B, 2C, that means This is the actual intercept, a face x is the actual x length. So along A, how much distance it has covered? So x by A. This is y intercept. So y by B. So that we can know at what length of A the face is cutting. At what length along C the face is cutting. So this is Z. So Z by C, that will give the intercept. Y by B, that will give the intercept along B. X by A, that will give the intercept along A. So 2A, 3B, 2C. So 2 is the intercept, 3 is the intercept, 2 is the intercept here. 2 times A, 3 times B, 2 times C. So this is the crystal of intercept x by A, y by B, z by C, where x represents the actual length from the origin to the point where the face cuts. Y actual length along B where the face cuts. Z is the actual length that the face cuts along C. That's why to know the intercept we divide x by A, y by B, z by C. For example, A is to B is to C is given 1 is to 2 is to 3. Actual intercept 2, 4, 3. So find crystal of intercept. So this is the actual length that has been covered. 2 by 1, 4 by 2, 3 by 3. These are the intercepts. This is 2A, 2B, 1C. So this is the Miller indices. This is the Miller indices. This is the Weiss parameter. This is the Weiss parameter. Weiss parameter. So this is all about the Miller's indices and the axial ratios. In my next talk, I will discuss on the laws of crystallography. Thank you all for giving a patient hearing to my talk.